हेलो स्टूडेंट, स्वागत है आपका डॉक्टर सौरभ से क्लासेस में। और आज हम लोग सॉल्व करें आईआईटी जेईई एडवांस का पेपर 1 2025 और हमने उठा लिया है क्वेश्चन 3। तो चलिए हम लोग कैसे ये सॉल्व कर सकते हैं देख लेते हैं। सो फर्स्ट हम लोग को चेक करना पड़ेगा लिमिट। सो वी विल चेक द लिमिट एज x टेंड्स टू 0। ठीक है, तो लिमिट x टेंड्स टू 0 और fx क्या होता है, लिमिट x टेंड्स टू 0 2 minus 2x square minus x square sin of 1 by ex, ये हमको दे दिया गया है। तो we know as x tends to 0 sin 1 by x क्या होता है, बाउंडेड बिटवीन -1 and 1। ठीक है, और माइनस x square is less than equal to x square sin of 1 by x that is less than equal to x square। so उसका मतलब क्या हुआ, माइनस एक्स स्क्वायर लेस देन इक्वल टू माइनस एक्स स्क्वायर साइन 1 बाई एक्स लेस देन इक्वल टू एक्स स्क्वायर। सो इसका मतलब है एफ एक्स इज इक्वल्स टू 2 minus 2x square minus x square sin 1 by x is 2 when as x tends to 0। तो फिर एफ एक्स क्या हुआ हमारा, is continuous at x equals to 0। अब स्टेप 2 में हमको क्या करना पड़ेगा, हमको डिफरेंशिएबिलिटी चेक करना पड़ेगा at x equals to 0। so now we will check the differentiability at x equals to 0। ठीक है, so let's compute the derivation from definition। so f prime 0 is limit h tends to 0 f of h minus f of 0 by h। so that means limit h tends to 0 2 minus 2h square minus h square sin 1 by h minus 2 by h। so that is equals to limit h tends to 0 minus 2h square minus h square sin 1 by h or limit h tends to 0 minus 2h minus h sin 1 by h। So this limit clearly exists as sin 1 by h is bounded and multiplied by h tends to 0। so what happens, so f at 0 will be limit h tends to 0 minus 2h minus h sin 1 by h is equals to 0। so we can tell that f is differentiable at x equal to 0। so this is option A। okay, so option A become false, we have to check all the options। so let's check for the decreasing nature now। next हमको जो दे दिया गया है, so for that हमको क्या करना पड़ेगा, let's find f prime x for x not equal to 0। so fx will be 2 minus 2x square minus x square sin 1 by x। so now differentiating using product and chain rule, so f of x will be minus 4x minus 2x sine 1 by x minus cos 1 by x. Okay, so if I directly differentiate, then 2 minus 2x square minus x square sine 1 minus x 1 by x, so that will be equal to minus 4x minus 2x sine 1 by x plus cos 1 by x. So, but crucially, if we observe for small positive x, for small positive x, fx 2 minus 2x square minus x square sine 1 by x. And we know that sine 1 by x oscillates. So the term, this one, minus x square sine 1 by x oscillates between which value? Between minus x and plus x. So for that, minus x square and plus and x square. So the overall function इसके लिए fluctuate हो जाएगा. But since it is minus x square times an oscillation, तो उससे क्या होगा? fx is always less than or equal to 2 for small x and approaches 2. So now let's try to find out such a small. Let's try to find out such that how f is decreasing in. So we will try checking the behavior numerically. Okay, so for let for small x like greater than 0 being, for small x greater than 0, so since f of x is 2 minus 2x square minus x square sine 1 by x is less than 2, and we know since minus x square sine 1 by x contributes oscillations of small amplitude. So the dominant term, that is minus 2x square, it ensures that the function decreases as x tends to. So B is true. Okay. Now for third one, we have to see. So here we have to claim that for any real number, for any positive real number, so here again the similar logic we have to use, correct? That which shows function is symmetric around 0. Function is symmetric around 0. So then what we will do? We will replace x by minus x. So behavior is similar. There can be small positive real number which increases so that the function increases in the given domain. So then this is false. And finally we come, is x is equal to 0 a point of local minimum? So we will check the values near 0. That is 2 minus 2x square minus x square sine 1 by x. So we know that sine 1 by x is minus 1 to 1. So then fx will be 2 minus 3x square 2 minus x square. So for small n of x, fx will be less than 2. Correct? That is equal to f of 0. So hence 0 is not a local minimum. So then, yes, you are correct. So my correct answer is option B. Best of luck, students.